So a couple of you have been asking me all year, what is a monomial? Well, today we are going to find out, and about polynomials too. So let's look at this vocab for a minute. A monomial is just an expression that's a number, a variable, or a product of a number and one or more variables. So some examples are 3, that's just a number, negative 5x, there's a product of a number and a variable. 2x squared y, that's the product of 2x, x, and y. That has a lot of variables there. The degree of a monomial is the sum of the exponents of its variables. A non-zero constant has a degree of 0, and 0 has no degree. So if we're looking back up at this problem, there's 3. It has no variables, just a constant. So its degree, I'll put d, is 0. Negative 5x, the exponent of its variable is x has this invisible exponent of 1, so its degree is 1. 2x squared y, x squared has, obviously that has an exponent of 2, and y has an exponent of 1, so the sum of those variable exponents, 2 plus 1, its degree is 3. Okay, so let's look at some problems. The first thing I want you to do is just tell me if it's a monomial or not and be able to explain. So try actually all 4 of these problems on your own if you can. So remember the rule, it's a number, a variable, or a product of number and variables. So the first one, 8ab squared, yes, this is a monomial because it's just the product of 8a, b, and b. Okay, 8ab squared, so it's the product of numbers and variables straight across. That's good. Okay, b, 3a plus 2b. Oh, this is not a monomial. The reason being it has a plus here, so it's the sum of 2 monomials, but the whole thing itself is not a monomial because it's not just product of numbers and variables. Okay, C, 4m divided by n. Okay, so this one's usually tricky for people. This is no. The reason being it's 4 times m, but then divided by n. So right here, this is not a product, it's a quotient of your variables. So that is not a monomial. All right, once you've seen that one, let's see if you've gotten fooled with this one. D, a over 5. All right, so at first glance you're going to probably think no because a divided by 5, that's a quotient again. But what you want to think about, can you actually rewrite this so that it is the product of numbers and variables? Dividing by 5 is the same thing as multiplying by 1/5. So we could rewrite this as 1/5 a, and you can see it's the product of a number and a variable. So yes, this is actually a monomial. All right, let's see if we can find out the degree of some monomials. So remember, the degree is the sum of the exponents of its variables. So go ahead and try these problems on your own and see if you've got them, and then I'll come around with the answers. So 18, it has no variables, its degree is 0. 3xy cubed, so x has a little exponent of 1. Y cubed has an exponent of 3. You're adding them. The degree is 4. 6c, so the only variable there is c. It has a little invisible exponent of 1. Its degree is 1. All right. More vocab. This is a very vocabulary intensive lesson. So, a polynomial, poly, you may know from English class or whatever that prefix means many. A polynomial is either a monomial or the sum, so adding, or difference, subtracting, of 2 or more monomials. So here's some examples. Negative 4x, that's just a monomial, but we call all monomials polynomials too. Confusing for some people. 3x plus 2y, that is the sum of 2 monomials. 3x and 2y are both monomials. We're adding those. Since there's 2 of them, we usually call that a binomial. Okay, the third one, Negative 6a cubed, see, monomial, minus 2a squared, monomial again, plus a, another monomial. But all together, we add or subtract all those terms. There are three monomials all there together. It's a polynomial. And most of the time, since there's three, we would call that a trinomial. Okay, so when we write standard form for a polynomial, it has its terms in descending order by degree. So if it's the highest degree for a monomial, like x to the third or something, that would be written before an x squared. And all its like terms have to be combined. The degree of a polynomial is the largest degree of any term of the polynomial. So, for example, if I look back up here, this trinomial, this first term has a degree of 3, this one has a degree of 2, and this one has a degree of 1. We'd call that degree 3. You just say the highest of any of the degrees, okay? Where in a monomial, you're adding up the degrees of all the variables. So if I had a polynomial like this, 6x squared y plus 9x to the fourth y to the fifth, you would have to find the degree of each part. So this one has a degree of 3. That's like an invisible 1. The second one, 4 plus 5, has a degree of 9. The largest degree of that would be 9. Okay, so that would be the degree of that polynomial. All right. So let's go ahead and look at this big chart. I highly recommend writing this whole chart down because you will want to refer to it quite often. So in many of these things, you're just going to hear a lot in your math life. So if I have a degree of 0, it has a special name. We call that a constant. It's just going to be a number, a constant. A polynomial example that has a degree of 0 is 6, 23, 1, negative 241.6, whatever. Just a number. In this particular polynomial, the 6, this constant, it only has one term. So when it has one term, we call it a monomial. Okay? So this degree goes with this name, constant, and the number of terms here goes with this name, monomial. All right, when something has a degree of 1, you've heard this name a lot, it's called a linear relationship, okay? Here's an example of a polynomial that's linear. X plus 3, so this first one has a degree of 1, this has a degree of 0, the highest degree is 1. It's linear, okay? In this particular case, we have two terms, an x and a 3. So when we have two terms, we call it a binomial. You could have a linear monomial, like something that's just like 5x or something, that would be a monomial, but in this particular case, we have two terms, okay? If something has a degree of 2, so like x squared, something like that, if you remember, we call that a quadratic. A polynomial example for this would be 3x squared, okay, or it could be 3x squared plus 2x plus 1. There's a lot of choices, but as long as your highest degree is a degree of 2, we would call it a quadratic. In this particular case, I only have one term, so again, I call it a monomial. Okay, let's look at some more. Third degree, that's called a cubic. So that would be to the third power. All right, so something like this. 2x cubed minus 5x squared minus 2x. In this case, we have three terms, so we call it a trinomial. Okay, these next two, number 4. If it's a degree of 4, so something to the fourth power, we call it a quartic. Oftentimes your book might also just call it fourth degree, getting into these higher ones, but it does have a special name called a quartic, so you might hear that once in a while. Here's an example of a quartic polynomial. X to the fourth plus 2x. So see, the highest degree is 4 right here. This one in particular has two terms. So when it has two terms, we call it a binomial. Okay, last one of these. A quintic is fifth degree. Again, sometimes your book, it might just call it fifth degree. Okay. And here's an example with the fifth degree, or quintic polynomial, negative 2x to the fifth plus x squared minus x plus 4. Okay, that's an example. In this, hopefully you can see there are 4 terms. When we have 4 or more terms, we just call it a polynomial of 4 terms, or like of 5 terms, of 10 terms, whatever it is. So just a polynomial of however many terms. Those don't have special names if they're 4 terms or more. Okay, so there's a lot of vocab here, as you can kind of see. All right, so what I want you to do here is write each polynomial in standard form and then classify it by degree and number of terms. So to get standard form, the first thing you need to do is highest degree is first, and all like terms are combined. So here there's no like terms. We have a negative 2 and we have a 7x. But 7x has a degree of 1 and negative 2 has a degree of 0. So we're going to write it like this, 7x plus negative 2, or usually I would just write 7x minus 2. That's more simplified. Okay, so this is my final answer for simplification. And you can see it has 2 terms, so it's a binomial. And the highest degree is a 1, so it's linear. So we call this a linear binomial. Okay, and you only ever classify after you simplify it and write it in standard form. Okay, so let's look at the second one. So like terms. I've got 3x to the fifth. I've got a negative 2x to the fifth. Those are my only like terms there. So when I add those, that's the highest degree, so I'm going to add it first. We just have x to the fifth. Okay, and 7x, that's going to go next. And then a minus 2, that's going to go last. Okay, so you can see here I have 3 terms and my highest degree is 5. So I would call that a quintic trinomial. Okay. All right. Adding and subtracting polynomials, you have actually done this a lot before, but you can only add or subtract polynomials by combining like terms. And remember, like terms have the same variable or variables raised to the same power. So those are the only things we're allowed to add or subtract. And so here's a couple examples that we'll look at. So for example, simplify this. Is in parentheses the quantity 6x squared plus 3x plus 7 plus, in parentheses, 2x squared minus 6x minus 4. Okay, obviously there's nothing to combine in this group or this group because nothing has the same term and the same power. Okay, same variable and same power. But this is all an adding and subtracting problem. I can subtract in or out of parentheses. I don't even need them there. So I'm going to look for my like terms. I'm going to color code this. So this is 6x squared, and this is plus 2x squared. So I'm going to do 8x squared. Okay, and then I've got a positive 3x plus a minus 6x. So 3x minus 6x, that's negative 3x. Okay, and then lastly, I've got a positive 7 plus a negative 4, that's positive 3. And I've combined all my like terms, and if I wanted to, I could say, hey, yeah, this is a quadratic trinomial. Okay, all right. When we have a negative sign here or a minus sign, we need to be a little bit careful. What I usually like to do is just distribute it all out because that helps me keep track of it. So I like to kind of go, hey, this is 2x cubed plus 4x squared minus 6, but I'm going to be subtracting this whole thing. So it's like kind of multiplying it by negative 1. Okay, so I'm going to distribute that negative sign to everything in here. So it's going to become a negative 5x cubed minus 2x plus 2. I like to do that because then it's just kind of a normal straight adding problem. I don't have to think as much about the subtracting and where that's going to get hard. So again, I'm going to look for my like terms. I got a 2x cubed here and a minus 5x cubed. So that gives me negative 3x cubed. Okay. Then it looks like this 4x squared, there's no other x squared, so that's just by itself. So I'm going to write plus 4x squared. And then it looks like this negative 2x, that's just by itself, so I'm going to write a minus 2x. But this minus 6 and this plus 2, they go together, and I've got a negative 4 or minus 4. So that's it. And I could say, hey, that's a cubic polynomial of 4 terms if I wanted. Okay, so this is kind of what I would like you to be able to do without me telling you anything on a whiteboard or paper. Could you write a cubic monomial, a linear binomial, a quadratic trinomial, a quartic polynomial, 4 terms, a 6th-degree monomial? Could you do these without looking up what these words mean? Okay, that's your goal. If you could do that by tomorrow, that will really help, so you don't have to just reference everything over and over again. All right, so this is something you really need to study. Flashcards are great. See you later.